Hello, everyone, and thank you for attending today's webinar, RAN Innovation in the AI Era, sponsored by Ericsson. Before we begin, I wanted to cover a few housekeeping items. Under your slide, you use the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. Also on your screen is a survey. Please take a moment towards the end of today's webinar to complete it. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Omdia's Senior Principal Analyst, Mobile Networks, Gabriel Brown. Gabriel?
Thank you, Barbara, and hello, everybody. Welcome once again to this webinar on RAN innovation in the AI era. It's a terrific topic for mobile network designers and engineers, and really for everybody working and involved with mobile communications. It's really great to have you with us today. Thank you for coming. We are certainly looking forward to it on this side. The AI supercycle, I think, as everybody knows, is having a huge impact and will carry on having a huge impact on the services we want to use over mobile networks, even allowing for some healthy skepticism when we look across the technology landscape at big trends like autonomy, robotics, transportation, energy, biosphere, you name it. There are a ton of things here. There's really quite a strong case for techno-optimism, if you like. And in this worldview, very clearly, the next phase of mobile is going to be, really epic. I think we have a great outlook here. So that's kind of why it's so exciting to be here talking about the technology and product that underpins it all. As you heard, my name is Gabriel Brown. I'm an analyst with Omdia. Omdia is an independent research firm focused on the broad tech industry. I, of course, work in our service provider group focused on mobile networks. I'm going to be your host and moderator for today. We have 3 terrific speakers with us from Ericsson. They're going to be joining us from their studio in Kista, Stockholm, that's Sweden, where they're going to be presenting from with a nice professional setup and so forth. So we're really looking forward to seeing how that works out. Let me just quickly introduce each of them. We have, first of all, Frode Dierdal, who is head of Ericsson Antenna System for the market area, Europe, Middle East, and Africa. We have Thomas Sandin, who is head of radio portfolio management at Ericsson, and Gabriel Foglander, head of strategic RAN leadership at Ericsson. Just in terms of the setup here, after a short introduction from me, we're going to hear from Ericsson take us through some of their materials. We are having some discussion and audience question at the end. We planned some time for that. You can submit questions for the speakers via the chat box on your screen. We have 3 really good speakers, very deep in the technology, deep in the product, extremely well known and connected in the industry. And I do know they want to take questions, so don't be shy. Technical, business, product, all of that landed on them. I won't read out your name or your company name when you send in a question. So from that point of view, you won't be your name won't be mentioned in public like that. I will just say though, please keep the questions sort of on topic in this realm, if you see what I mean. There's no point asking a question of some random thing, so I won't be able to use it. Finally, just to say, some of what we're talking about was launched 2 days ago at London's Analyst and Media event. You might have seen the press releases and so forth. So a good bit of the session today is going to be a deeper look. But again, if you have questions or comments, please fire them in on the tab on your screen. Right. So I'm going to set up now just a little bit how I'm looking at this from an independent analyst point of view. And I think really in the first instance, we have this explosion of AI-enabled endpoints that really should and is creating an opportunity for mobile operators to serve and monetize this market. These new applications, device types create a need for always-on, consistent, low latency and reliable connections. And so from my point of view, for operators, this is the most important play in AI right now in the near term. Those operators with a strong 5G SA networks, of course, have a good opportunity to monetize in the near term. Then, of course, as we know, as we get into technology and product and equipment and so forth, then yes, this can all help deliver a better service, better efficiency, application performance, and user experience. So a ton of super interesting small pieces and massive pieces of technology that are going to really have an impact here. That's a good amount of that we're going to be getting into. I think the first role is really to apply AI to the network, and ultimately, as we roll out, longer term, it's an AI native kind of play. There's going to be a transition phase, in my opinion here. Right. So I have a final slide before handing over to Thomas. What we see is when we put these two circles kind of in combination together, we really have sort of a fantastic potential to create networks that adapt and respond to the context, to the user context. That's really the big opportunity. So it's the sort of cross, the intersection of these two circles. We're starting to see a few examples of that already. There are really a lot of applications where this is going to be relevant. I have a few on the chart here. We see very, very heavy demand on the RAN. It's not letting up, and it isn't years away. It's right now. So some of the use cases you'll see on the chart here, they really do need enhanced network performance today. There are a bunch of other examples I could have used. And I suppose fundamentally, for today's topic, need to think about how all this converges down onto the RAN itself. So that's the antenna system. Don't sleep on the antenna system for sure. We're going to get into that, and you're going to see some pretty interesting view on why that makes such a big and impactful difference. But into the RF chain, the radios, massive MIMO, regular RRH, and down into the baseband as well. So there's lots of places to touch and really optimize. From the operator point of view, we know they need and that they want service-aware capability in the RAN. That gets called different names, but I think service-aware gives a good sort of sense of what we're talking about. How operators do that, I'm going to leave for Ericsson speakers to propose and discuss, but there's definitely a need there. Just one final build now before I hand over to Thomas. I think a very quick point, but a big one, and very, very topical among the operator community. For many of these services, the uplink is really of increasing importance for users already today. Even before we get to AI, we have things like video calling, 5G laptops, fixed wireless access. All these kinds of things are really actually already changing the traffic profile. And so you see reports from operators, either formally or in background, that their uplink is growing a lot. Obviously, it's coming from a much smaller base, but uplink is really growing pretty fast right now. Then, of course, when we bring in all these AI applications, some interesting potential there. It could be another step change on uplink. So this is very important. Of course, mobile network systems are uplink limited. So again, there's really going to be a lot for vendors and operators to solve. I'm not going to attempt to do it. What I'm going to do is hand it over to Thomas and leave the sort of challenges, a bunch of challenges there, and leave them on his lap and his colleagues at Ericsson. So with that, Thomas, I'm pushing you out onto your first slide here. Please take it away.
Thank you so much, Gabriel, for a nice setup there. I would like to welcome you all to a new playground, where essentially we're talking about the new intelligence era. And it's really about two fundamental questions that our customers are scratching their heads about. On the left-hand side, you can see, and it's really, how do I prepare the network and how do I monetize these new AI and AR applications? And the second one is, how do I embrace and leverage AI into the traditional KPIs such as performance, TCO, and carbon savings? And we are indeed having a focus on the uplink because it's really a challenge. Why is that? Well, a reality check shows that the majority of networks out there actually struggle to deliver a consistent 1 megabit experience. That is to say, everywhere and at any time. And at the same time, we also expect that the uplink traffic will grow by as much as 3 times the next 5 years. And actually, when we look at the networks even today, the uplink growth is actually bigger than the downlink traffic growth as we speak. So this is already happening. So in essence, if we design networks for the future, we cannot look where the puck is. We need to be looking at where the puck is going. And with that, Ericsson's ambition is, of course, to help our customers to build the best networks for AI and also the best AI for networks. So that's sort of the let's say, setup for what we are bringing to the table then. And yes, we had the launch on Tuesday. It was a big splash. And what was the scope? Well, essentially, if you look at it from a product point of view, it was 10 new radios, massive MIMO and multiband radios for classic, if you so wish. And then also 5 new antennas, where 3 of them being interleaved with beam-through technology, and also 2 passive then. And on top of that, actually also a street sector configuration where we are able to bring the radios closer to our customers' customers, and then with that improving the uplink, of course. And last but not least, also great AI RAN enhancements, 3 of them, together with 2 latency enhancements for AI that Gabriel will talk a bit more of in just a while. But I mean, product is one thing. What is it all about? Well, it's actually it's a full suite of uplink performance solutions, both for macro cells and also for small cells, outdoor and indoor as well. The second thing is really this full stack AI architecture, where we are now also adding AI into radios, and where we're also bringing in neural network accelerators into Ericsson silicon. And third, but not last then, or actually it is the last point, is really a new radio lineup, an industry-leading lineup for network consolidation and RAN sharing, which actually provides leaps when it comes to performance, TCO, and energy savings. So that's the content that we will go through now in greater detail. And Ericsson is really unique in implementing this full stack architecture. And what we're really bringing as a news here is that we also now run inference in the radios. And with that, we are actually providing now a comprehensive radio portfolio. And inside the radios, we will also then have silicon with these new neural network accelerators to bring out new performance and take it to the next level. But I'll hand over here for you, Gabriel, to elaborate.
Thanks, Thomas. I want to pick up the ball here and talk a little bit about what Gabriel mentioned in the beginning. Because you see, the end goal here is for us to be able to support operators in making a service of our own that uses all the capabilities. And since we can all recognize that the AI technology is moving at lightning speeds right now, it is really important to arrive at the right architecture to be able to successfully draw on that. And I think what we show on the slide here is we are, in principle, embedding AI at every level of the stack, and in the degree that it makes sense to do it, because not all AI models are the same. So as an example, in the RF layer or the SMO architecture, you can draw on larger data sets, and you can have fairly large models with millions of parameters, but also kind of shorter inferencing, longer inferencing intervals. Whereas if you go down to the RAN stack at the distributed B, we draw on compute level, but the time to complete is extremely tight with the latency requirements, which means that you're moving with smaller models, fewer parameters, but really lightning fast inferencing. And if we accentuate that even further, as Thomas was alluding to before, we're now also preparing the radios with equipment to do also inferencing for the lower layer of layer 1, where the kind of the time constraints are even more critical, and the raw data is tremendous. So in essence, this chart summarizes our strategy to really implement AI where it makes sense, and that we have a different approach to implementing AI depending on what layer of the stack you're talking about. So let's take another look then at what we do specifically in the RAN software. We talked about in the beginning, you were mentioning that we have networks for AI, which is essentially how do we cater for the needs in this network where new workloads come into it and new needs are emerging. And we see some consistency there. We see that, larger uptake of uplink is there. And for sure, we also see kind of bounded or sort of consistent latency is also a common denominator among these applications. So with the kind of product feature set that we've had in 5G Advanced on the software side, we're now taking another step on that and optimizing further for the latency part. So we have a scheduler mechanism that can keep control of a low variability on the latency side, which is really important if you process time-critical round trip times, or in the end, if you're going to process tokens, if you will. We have the same kind of support when it comes to a lower level of mobility, so LTM and supporting mobility switching on layer 2 of the stack in technical terms. And both of these have the common denominator that they protect the end user experience if you have applications that are really demanding on the latency side. If we look at on the right-hand side, we talk a little bit more about what we're implementing to promote the efficiency, as you call it in the beginning here, Gabriel. And we're adding now to the AI native link adaptation 2 new AI features with the AI-powered beamforming and also the AI-powered outdoor positioning. And they have a little bit different objectives. One is really making better decision at what beamforming schemes to use based on real-time data, and thereby kind of optimizing the capacity, unlocking better downlink throughput for the users that really need it. The outdoor positioning one is enhancing the positioning accuracy of our services, and particularly it improves when we're in non-line of sight conditions, which is quite common in the networks. So therefore, being able to use AI to increase up to 5 times the positioning in those conditions means that you are much more precise with these services throughout your network, unblocking you to launch positioning-related services to your end users. So it's an amazing lineup here with AI software, and it all runs on fantastic hardware, Thomas.
Thanks, Gabriel. Yeah, let's continue with hardware. Well, when we talked about how we then introduce also radios in this full stack, it's also important then to have the right hardware, as you say, Gabriel. Now, we have a very long track record of being future-proof, both if you remember the ERS portfolio that was 5G ready, and last year we talked about how comprehensive our portfolio is to support Open RAN or being Open RAN prepared, and that very same portfolio is also AI ready. So a extremely comprehensive portfolio of radios that not only is Open RAN ready, but also then AI ready, which means you buy an Ericsson radio today and you can go towards openness or implement AI, at your pace whenever you want, at the pace you want, right? And with that, having 160 pieces of radio variants with more than 75% of the shipments this year being AI ready, then that's a industry reference I would dare to claim. Now, what does this build on then? If you look at our silicon lineup of today, we normally say that we have tailor-made silicon for the different product types, meaning we have 1 chip for the baseband, we have 1 for our remote radios, and then 2 chips for our massive MIMO radios. And then we say that we have a yearly cadence, meaning that each year at least 1 of these chips is renewed. And when we do it on the highest integration node. And as of now, we're already at 3 nanometer in products, which is based on this digital front end then. And then we are along, or let's say already executing on plans to also bring 18 angstrom later on. Now, if we look at the left-hand side, the RAN compute, which is running this inference already today with the AI native link adaptation that Gabriel was talking about. That is based on having a so-called Ericsson many-core architecture in that chip that, for instance, has DSP pools, right? Now, what you probably are maybe not so much aware of is that those DSP pools also reside into our remote radio chips and our beamforming chips or massive MIMO radios. So we are actually having this Ericsson many-core architecture already in those chips, right? And so when we say we can do inferencing in the RAN compute, actually it means that we can do it in our radios as well. So that's the starting point. Then we spice it all up by introducing a new IP in the massive MIMO beamforming chip, which is neural network accelerators. And this is super exciting. This is essentially a large pool of tensors which are programmable to do either beamforming or AI inferencing, right? So with that, we can run a massive parallelism and ultra low latency that sort of fits with these models that are perhaps not as large in parameters, but are super latency critical then. And this is really a news that we are sort of launching in this launch then. So what can we do with this capability then, right? And here we are proud to then announce that we are introducing AI-powered receivers. And what does it mean? Well, essentially we're attacking the most difficult part of the receiver, which is the channel estimation. Channel estimation is essentially operating at very low SINR, or signal to interference and noise ratio levels, because of the many branches that we have in the massive MIMO radius. So they are quite sensitive to noise and interference, right? And now with AI-based implementation, we can improve the quality of that channel estimation under these circumstances. That is to say, low signal to interference and noise ratio, but also non-line of sight. And we have a gain potential of up to 20% in those conditions. And I'm actually quite happy to also say that we are already live with this proof of concept, running prototype software on commercial hardware, the AIR3255. We have seen these 20% materialize in trials, both in Sweden and actually with the lead customer also in Europe. So we are super excited about this capability. And the good thing is that this chip resides not only in the 3255, which we are already deploying in LATAM, in India, in Europe, in Japan, and even more places, right? But it's actually coming across our latest generation massive MIMO portfolio. And we actually have, as you see here, 10 product variants on massive MIMO by the end of this year that have this capability. So this is very much a here and now thing, right? Great potential. Super happy about that. Now, we were also talking about how to improve the uplink, and a few of you might have followed the FDD Massive MIMO webinars that we've been running last autumn. Gabriel hosted that one as well, where we see fantastic improvements on especially the uplink, where we see easily 3 times and sometimes up to 4 times capacity improvement with FDD Massive MIMO on these mid-band, which is a very large spectrum asset that you can sort of multiply this capacity. But we also saw that you can match the coverage of the low band so that you can do offload of the low band. So fantastic potential with massive MIMO. And then we also have this 8 receive solution as well, which is very neat because normally you don't have to touch the antennas. So we of course have 48R radius, and in this launch we also have a high power version for US. And then for Europe, we are actually coming with a complete new innovation. In Europe, many operators has the SDL, or the 1500 megahertz band. Normally you would slot another radio there to 4 ports of your antenna. But we're adding 4 receive branches on band 1 and band 3 in that radio. And if you combine it then with the regular 44R radio for band 1, band 3, all of a sudden, not only do you get the SDL band, but you also get 8 receive on the uplink. And all of a sudden, you double the capacity, you improve the throughputs, and you are better off serving SLH users if you so wish, right? And all the way to the right, I'm quite happy to also give a bit of a teaser to what Frode is going to talk about. We have new generation passive antennas with increased beam efficiency and also PIM mitigation, which also has the potential to give another 30% performance, both downlink and uplink. So this is kind of the suite I was talking about, macro solutions. I will not have the time to go into the outer small cells, but there we have a street sector, and also in our indoor radio dot system, we are bringing spatial uplink multi-user MIMO, which essentially quadruples the capacity for these 5G laptops or for factories or whatnot. So again, with this launch, we are really coming out with a battery of new uplink performance solutions that are then very much meeting the challenges of a AI era, if you so wish. Then I was talking about these network consolidation portfolio. And some of you that might have followed the launch on Tuesday also saw that we had a guest speaker there for Vodafone 3, which is driving a massive network consolidation in the UK. And the setup there is that not only are they combining the spectrum assets of Vodafone and 3, but also they're doing network sharing at the same time with Virgin Media O2. So essentially, they're combining 3 operators' assets, and they do it with one new radio from Ericsson on low band and on mid band FDD, right? So we're bumping up the output power to 720 watts and adding only 1 kilo as compared to the industry leading 4485. It's a remarkable improvement in capability, right? And similarly, we're bringing the low band up to 720 as well. Low band is a little bit more difficult when it comes to filters and so on, so it's a bit more heavier. But these are the 2 new radios that we are then adding to our fantastic R3266, which is an industry-leading massive MIMO radio for Europe as well, that has up to 400 megahertz of spectrum, but also 400 watts. So this is ideal for network consolidation or network sharing as well. So with this lineup, I mean, it's amazing savings that we're doing, right? So compared to a 2021 portfolio, we're saving 44% energy and 65% embodied carbon. So this is also fantastic from a carbon emissions point of view and a TCO point of view. And let alone also look at the antennas there, right? With Frode's antennas, we are also bringing down the rental footprint as well. So this is really, I would say, by far the most leading portfolio for network consolidation and RAN sharing. And this is happening not only in UK, it's happening in France and Italy and also Spain. So, and those are huge markets. So this is quite important. Now, in the launch, we of course didn't go to all the details. I will not go into the details to a higher degree here as well. But we're in the launch. We have 6 new multiband remote radios. We already talked about the 3 to the left. We're also bringing in new generation triple sector radios, and we're also then adding a new outdoor small cell, which combines 2 bands for US, then in a very small footprint, you get both the PCS and AWS bands. So this is then both, can be put into a shroud, or it can be put into this street sector solution that I was talking about. So that's a great lineup that we're bringing. And then on the massive MIMO side, we are really taking leaps in performance, I would say. So all the way to the left here, you see a 600 megahertz IBW product that can combine 3 carriers of, let's say, operator spectrum then in 13 kilos only. This is for Japan, especially tailored for operators there that can then have these 3 carriers distributed across more or less the whole N77 band. And we do it in 13 kilos. This is unheard of. Going all the way to the right, we have now for the first time a combination of FDD and TDD within the same massive MIMO radio. This is targeting the India market. And then in the middle, you see two high-power TDD and FDD massive MIMO radios for the US market primarily, where we are bumping up the output power on TDD to 480 watts, adding antenna elements up to 256, and with that sort of getting a much higher EIRP. We're improving the uplink with the say more antenna elements, and of course all of these massive MIMO radios comes with the capability of AI-powered receivers so that we can improve the cell edge here as well. So this is also fantastic news for are markets where these radios can be put. And then to also almost bridge to Frode, we'll talk a little bit on antennas. Last year we introduced 2 interleaved antennas, which focused on bringing 2 massive MIMO units with beam-through technology to provide great flexibility for that. Now we're adding 3 more combinations, which are kind of FDD or TDD only, right? But this just beef up the, let's say, flexibility and the capability of the interleaved portfolio then, which is by far the most flexible and the most comprehensive in the industry. And with that, I think I will hand over to you for that.
Thanks, Thomas. Thanks, Gabriel. Really appreciate exciting news and exciting area that an era that we're living in. I want to talk how about to play it efficiently. In the antennas, as we have talked about, we have been driving for years design process, which is really digital twin based and simulation based in order to get the most out of our antenna products and the antenna patterns. And as we can see now that we are taking these new antennas to the market, we are continuing to accelerate on this, which has a tremendous impact on the uplink, of course, as well as the spectral efficiency. I will go a little bit more into how to really evaluate this and look at this later on in a separate slide. But of course, we are bumping up the beam efficiency, a measurement that we are using to really see the amount of energy that we are putting into the cell and not as interference in the network, which is already interference limited, or as wasted energy into the sky. Then we are continuing to really drive this 156 dBc PIM performance in our antennas. And these 2 things together is really critical when we are talking about network consolidation. You're going to handle a lot more power and you're going to handle a lot more PIM bands that has IM3 hits. So it's really important here in this consolidation phase to have a very efficient antenna that is also a really well PIM performing. Then we have focused, and I also have some slides on this, on how do we really bump up the carrier aggregation usage in the cells. So how are we making our cells stack on top of each other across all the layers in order to drive as much carrier aggregation as we possibly can out of the network to make it as spectral efficient as we can. Then I guess the intent, the really how should I say, the really exciting news is also how the antennas now can start to contribute into the AI part of the network. So the way that we really see this now is last year we launched a very secure and certificate handling in our RET motors so that we can really secure this software integrity in these units. Now what we're doing this year is to really put positioning. We can put the tilt and roll of the antenna into the antenna itself, and that will really help to drive a lot more data, which algorithms and the AI large language models can use to really evaluate. And I have one quite a fact here. So if you look at an antenna with a 1 degree tilt inaccuracy, it roughly results in about 25% less throughput at the cell edge. So to really understand where your antennas are, how they're installed, and what direction they're pointing in is really important for your network performance when you want to squeeze the most out of your frequency spectrum. So I want to talk a bit about this picture, and I'll try to break it down a bit. If you look at the top, you will see basically a photo or an illustration or a simulation of our latest Tri-net antenna and how all the different layers are stacking on top of each other. If you look in the bottom, this is sort of an industry average that we have taken. And what you really find by accurately positioning this on top of each other, we're seeing that we are driving carrier aggregation in the networks. And I think the important piece about this picture is that you cannot actually read this out of a data sheet. So in order to read this, you will have to look at or 3D patterns and then basically evaluating 3D patterns. We have also launched recently and have accessible a paper which demonstrates basically the role of passive antennas in 5G standalone and how exactly this technology can really help to not only shore up that you have the capacity that you need to sell differentiated connectivity, but you really also can get the absolute most out of the network. So talking about antennas, and I want to talk about this from a modernization piece as well, because often we are forgetting to really think about the antennas when we are doing network modernization. But now, especially in this uplink area, I think it's important to really also include this. We see through our beam efficiency and through the pin performance that we have in our antennas that we take out about 30% more uplink throughput. And this is basically uplink throughput on top of what Thomas spoke about in the network. So if you use 8R, we still are going to deliver a better uplink on top of that. Also, another part that I will talk about is now differentiated connectivity, really important for the industry. And this is also an area where the antenna really can play a role to drive carrier aggregation and improve the spectral efficiency. Network consolidation, we talked about it. It is a lot more bandwidth and a lot more power that is being put into the FDD bands. And here you need this pin performance in order to make sure that you really have a good network performance and a good receive sensitivity. We're also talking about, and we see now a lot of 600 megahertz discussions going on. So this is also something that we really are preparing and that really putting forward. We see markets in North America, Mexico, also in the Middle East, rolling out 600. So this is an important consideration for also all to have. And of course, when it comes to the tower space and the rental area, we have for a long time with the really light honeycomb housing and the very easy to install system been working on reducing this. We also have the best wind load performance in the industry compared to our size due to these vortex generators where we are really breaking up the vortexes and we're making sure that we have the least resistant here. We also have a paper where we have, together with a standardization agency, really done a deep dive into measuring antennas for tower impact. And we will be releasing this in Mobile World Congress, where you can really see the much more detailed study on how we actually should measure or could measure the wind load. Then fundamentally, it's about the security. We really have built in now this digital certification handling to secure that no malicious code can enter into the antenna. And this we will continue with. And in addition, of course, we are also bringing in this basically we're bringing in the positioning, the tilt, and the roll into the picture as well. So this is, in my view, this is somehow one of the biggest reasons for why we should also look at antennas when we are doing network modernization. I'm going to take you to this picture. We've used it quite a lot. This is somehow where we have this is where we have gone into the industry and actually basically done benchmarks and looked into to deep dive where or how our antennas is actually impacting the network performance. And you will see here everything from uplink. You will see also you will also see energy consumption. But the one that I really want to point towards now is where we have actually tested this in 5G standalone and what this means for the 5G standalone network. And what we're seeing is, of course, at the same behavior, but even better in 5G standalone when it comes to uplink performance. We're moving a lot of traffic from VoLTE to VoNR because of the way that our low mid bands are so precise. So it makes it much easier for the terminals to latch on to the mid band. And we're seeing the same behavior as we've seen before, where we really are saving the UE power consumption. So this is 44%, or I would say 3 hours of power consumption that you're saving by having a much more accurate uplink. But thank you very much, Gabriel. Then back to you.
Thank you, guys. What a great presentation. So we're going to have a little few sort of pre-prepared kind of questions and talking points I have. I'll pick up on a few of those pieces from the talk there. But also we're taking audience questions. We have a couple in already, but if you do have a question, put it in, and you know the drill by now. But you know, please do, and please take advantage. So loads to reflect on in that. I'm using VoNR right now, Frode, on EE in London. It's brilliant service. Honestly, it's glitch free, and they've got the 700, of course, as their low band. Really impressive. Let's go to the uplink question to start with. I'll go to you, Thomas, first, and then back to Frode. Thomas, when we think about uplink, you set out a whole range of kind of toolkits there, different techniques. Is there a particular phrasing or a sort of a dominant evolution path or recommended path that you're seeing or recommending to operators in how they boost uplink, or is it kind of depends where you are and you do it differently each time, each operator? So what would you recommend here?
Well, I think that my recommendation would really be to look at your network as a full asset when it comes to the full layered cake, right? You have the low band FTD, you have the mid band FTDs, you have the mid band TDDs, and you have even millimeter wave, right? So I mean, it's important to look at this as a network performance that together sort of combined provides the user experience, and there are a number of things that can be done, right? And some of them are actually hygiene, right? First of all, going towards SA and to really benefit from the carrier aggregation that is more efficient, there is kind of a no-brainer, right? And then the second thing is, of course, to make sure that on 5G you have it on the low bands as well, the real low bands. And ideally, you should have 4G and 5G on all the low bands, across the line, even with 44R and so on, right? But I think when it comes to a game changer, it's really the FTD massive MIMO on the mid layer, right? Because now we're run trials across the globe, and we have now the first operators really starting massive deployment, right? And really, those of you that have been to those webinars, the performance is astonishing, right? 4 times the uplink capacity, 8 dB improvement on coverage from beamforming and this IRC receiver, right? That's huge. That's really sort of matching the low band. So that's really making a dent. And having said that, that's really important. Also knowing that when we go, towards the future, we will add 6 gigahertz and so on, and of course the uplink will be central, coming from the FTD there as well. Last but not least, I would also like to say that the millimeter wave with the more antenna elements there as well also does a good job. So holistic way of approach, but the FTD massive MIMO as a game changer. That would be my.
Yeah, good stuff. Frode, you want to jump in on that, or I can set you up a little bit? I mean, my question for you here was that you talked about the uplink gains you're getting are not necessarily visible on a data sheet, right? This is something I have to model and then look and then test in the field. Essentially, I'm just wanted to get a little sense from you if I'm an operator deploying this, how do I actually see these performance gains you're claiming here? Like, what's the route to observability of these gains, I suppose?
Yeah. So I think the best and easiest way to see this is really to request our 3D pattern. This is the antenna pattern, but in a full 3D sphere. Then we have also developed some open source code that makes it possible for you to compile, and then you can really visualize how the antenna pattern would be in 3-dimensional. Given that, you can really set your boundaries. We have suggested some boundaries which we find is the most efficient one from a simulation point of view, and then you would really see and be able to see how much energy that you have inside of that. So this, I guess, is the first really important piece. Then, of course, the second piece is the PIM performance of the antenna itself, and this you can actually read from the data sheet. So here we are stating it on our data sheet, and given these two pieces, I would say this would give you a really fair idea on how an antenna would perform in the network.
Yeah. Okay. Good stuff. Thanks, Frode. I'm going to dive into a question now. We've got a good bunch coming through. Gabriel Foglander, I'm going to land this on you, but Thomas, come in. Frode, come in as you feel. This is from a North American operator. I'll just leave it at that only. Many of the products you have deal with putting AI in more places. Placing more computing on the edge can be very expensive for a lot of reasons. How are you working with operators to ensure that this is adding monetary value to the network? So the two things really, the cost implications of these AI deployment, and then what value it delivers. Maybe start with the first point, the cost implications, because there's actually several questions around energy consumption as well that relate.
Yeah, thanks for the question. I think it's a great one. If you consider the worldwide kind of attention on AI, I mean, there's maybe not too many things that we can claim to be the absolute best in the world at when it comes to AI in general. But we do have specific knowledge about the RAN domain that we can use. And one of those examples is solving for that exact same problem that you mentioned. So we realized that this TCO challenge of putting more compute at every single antenna site is going to be daunting, right? So the approach that we have taken is that we really work hard to fit the AI models that we developed into the envelope of our existing products. So we really do the West work to say, what are the least amount of parameters in that we can use, and how do we compress the model itself so that it can actually run on the same hardware that you already bought. And that's a design philosophy that is sometimes a bit more challenging, because when you evolve the models, it's easier to keep them large, because then you can play with more options and you can decide what to do. But to really be able to make it kind of deployable without kind of increasing the TCO envelope, then that is a kind of applied technique that we really fight hard to be at the best or at the front for. And the result of that is actually that we do deploy in our later versions of the basebands, we do deploy it straight into the baseband, no additional investment needed at all. And then, of course, I mean, if we look ahead 5 to 10 years from now, we are embracing the fact that the network architecture could evolve, and it could make sense to place additional compute for different purposes in the RAN domain as well. And for that, we are working really hard on the portability of our software to make sure that we can capture those opportunities as they arise as well. So that's my two-pronged approach to that question.
Yeah, cool. Thanks, Gabriel. Thomas, do you want to come in there and just talk about the footprint impact on the, you talked a whole bunch of stuff about the DSP pools and all of that. What is the hit you're going to take for these new algorithms or models?
No, but this is a very good question as well, because what's so exciting here is, of course, that we are working on very high integration nodes, meaning that we can put a lot of compute inside our 3 or 5 nanometer circuits, right? And then when we embed these tensor pools, in parallel with the DSP pools and their already available RAN accelerator pools, it just becomes one more IP in the full system on a chip, right? So when we add a lot of compute there, it's actually done with very low energy. It's super energy efficient, yet still very computationally heavy, right? So it's an art, like Gabriel was talking about, to sort of get the models in let's say, as big as possible, but as critical as possible, so that we can run it inside the chips then. So I mean, this is a journey has just started, right? So we are just in the beginning here, but we are all excited of where this can take us, right? And then having the capability is better than not having the capability. Simple as that.
Maybe I could just follow this up a little bit. You mentioned in your talk 75% of your radio shipments, I think it was radios, could have been baseband, 75% of your shipments in 26 are going to be AI ready, I think was we can check the slides, but something like that. Just explain a little bit to me then how you, as an operator here, how you consume these neural network accelerators. Like, are they something that you buy separately from the radio? It's a software release, it comes with your standard release on your 6-month or yearly release or whatever. Just try and help us understand how they get from your software factory into the operator's radio itself.
Well, it's a very good question. As also something that we are also starting a journey on, right? But I mean, like when we introduced the baseband or the RAN compute already with the 3.1 and the 4 generations, we also said that they were, let's say, AI capable, and that we added capabilities also in the generation 4 baseband, right? So similarly here, we are having a capability, and we will of course have software coming into that as we go along, right? And these neural network accelerators, they are indeed on our latest beamforming chips that sits in the massive MIMO radios. So there it's embedded, right? And then how we will sort of put that into the market is still a bit early to talk about. But I should just say that, I mean, these chips comes in the latest generation massive MIMO radios, regardless if they are sort of bought or not from the operators.
Yeah, understood. Okay. Do you have a sense, and this is a really unfair question, you've had no prep on it at all either, but you talk about quite a few of these examples where the different AI modules can give you a certain amount of gain, where it's 10%, 15%. When you think about it, okay, well, let's go to you first, but Thomas, you want to come in. Do you have any feel for what that all adds up to? What does that net out to? I mean, we could have 15% or 20% gain in a little area. It's only 1% on the final system kind of thing. So that's the first part of the question. And then what's the runway? Do you think there's like loads more gain to be had here, and we're just in the early innings, or,
Yeah, you're completely right. So the fact that we communicate often is like you need to be giving a message on what is a measured and isolated impact. But then, as we have been discovering during the session, right, the RAN system is a complex thing and it operates in a live environment, which means that, the way a certain functionality adding into that environment will augment the existing one is depending on so many parameters, which is why it's really hard for us to give like a specific net increase in a particular network. That's typically something we do when you kind of implement and you observe. Then you can do more like alpha beta comparisons. But then the kind of drawback of that is that they become quite operator specific, because it's hard to replicate exactly that same environment. But if we go from that statement, that's actually the kind of launch pad for why I'm so excited about what's ahead. Because, I mean, we just had the example of 1% tilt is missing out. And I think what you can kind of reasonably deduct is if you do that correction, then you will also see a bump in efficiency in the software that we put out, right? So there's an interplay that's happening here. And if you compare it to like an orchestra or something playing a classic suite, all the players can be playing the exact right notes, but if a couple of them are a little bit off pace, let's say, then you would kind of perceive that as a listener. And I think it can be a little bit the similar way in Iran's kind of system that is deployed, that all of the components are doing their job in a good way, but the coherence can actually be augmented if you have like an intelligence that ensures that they play a part. So I can exemplify, we're now doing a model for coverage prediction, which is essentially a fundamental capability where you kind of remove the need to signal back and forth to the device, because this is kind of a important information to understand how you do traffic steering and other things. Now, if we can have better prediction rates without signaling to the device, we can do all sorts of clever things in how we connect that to different utilizations of the different features. Indeed, the carrier aggregation, as you mentioned, is a good example of that. And thereby, if you have like a smarter prediction capability, you can actually orchestrate better, and therefore the round system performance will, as a whole, function better. It's really hard to put a number on it, but I'm super excited. I think we have more to cover, and that is despite the fact that we are already comparing to probably one of the highest benchmarks in the industry in terms of actual performance delivered in field. We tend to be at the top when we do these benchmark ratings. I mean, someone else can say that they do a larger percentage gains, but they typically haven't demonstrated this level of performance in live networks when they say that. They're starting from a lower comparison point.
Sure,
so percentages is a bad metric in some way, but it's needed to say what's the isolated impact.
Yeah, good stuff. Talking of percentages, I like you, I really picked out Frode's comment on a 1% antenna misalignment and the impact on cell edge. Pretty massive, Frode. Do you want to just, I know we've got 5 minutes left. I just wanted to come back a little bit to, or pick up on anything if you like, but one thing I wanted to come back to was this consolidation play that's ongoing. Definitely in Europe, it's a huge, essentially a restructuring of the whole sector, really, from a financial and ownership point of view, expressed through network sharing and various different modes there. From your position on the antenna side, how are you sort of managing to take that interplay that Gabriel was just talking about, essentially deliver better impact into the rest of the network from antenna performance as you go through very complex transitions really here?
Yeah, and I think it's an extremely exciting transition and a much needed transition as well for the industry. So I will hand over to Thomas, but from an antenna point of view, we really look at this in a couple of areas. The first area is the total power that actually goes through the antenna in such a scenario. So in a very complex RAN scenario, when three operators are sharing, we can see the total radio output power at close to 1800 watts, right? If you take all the bands and you combine them together. Now you really need to handle that power inside of the antenna, and you need to handle it extremely efficiently so that power actually gets put into the cell. Then, of course, you need to handle any PIM products also. So this is really, from us, the ability to handle power even when the antenna is vibrating and it's a really warm day in a country, as well as being able to have this PIM stability. That is the main thing. But our efficiency and our beam efficiency here is the opposite of what Gabriel said. I mean, here the percentage really matters. When you have this huge amount of energy, if you have 10% of that going into the interference area, that is having an impact on your network. So this precision and precision engineering is really the area we're looking at it. But Thomas, you also have a lot.
No, but I think that this kind of revolutionary breakthrough where we can sort of add from 480 to 720 by adding only 1 kilo, that's of course taking a step in power efficiency in wideband power amplifiers. So this is really, a technology step that we're taking. That's a clear one. But also then coming back to what Frode was saying, we need to cool it as well. And here we are very exciting new cooling techniques that we are also using in these radios. So again, if you have listened to me before, you need to master the 5 disciplines in radios. It's power amplifiers, filters, silicon algorithms, and the cooling, right? So it all comes, it needs to be balanced. That's how we design the radios to fulfill these, let's say, requirements, extreme requirements, I should say.
Good stuff. So on that note, we have literally 1 minute. We have many other things we can talk about. For anyone heading to MWC, obviously try and grab these guys and so forth. Just really remains for me to say thank you very much, Thomas Sandin. Thank you, Thomas.
Thank you.
Gabriel Foglander.
Thanks, my pleasure.
And Fleur Dierdal as well.
Thank you very much. It was a pleasure.
Okay, finally, just thanks to everybody in the audience for attending and participating, submitting questions and so forth. Thanks for joining and goodbye.